Dear scholars, I am Kai Hao, a master candidate from Nanjing University. Today, I will report our study on behalf of our research team. The co-authors of this work are Chunyang Chen from Monash University, Sebastian Bills and Christoph Trude from the University of Adelaide, and Xiang Chen from Nantong University. Since our paper received the ACM 6 of the Distinguished Paper Award, we would like to express our appreciation to the committee for their acknowledgement of our work. In recent years, software engineering is experiencing rapid development. As a result, developers need to continuously acquire new skills. When developers encounter programming-related questions, the common practice is look for solutions on programming QA sites. Stack Overflow, which is the most famous programming QA site, has over 14 million users, over 21 million questions and 31 million answers as of April 2021. This makes it difficult for users to find satisfactory results. Two semantic gaps can lead to poor query results. The first is the semantic gap between the user's query intent and the query words. Users have difficulty in using accurate software terms to describe their query intent, and any non-standard or mDrush expressions will lead to extremely low coverage between query and post content. A large number of relevant posts will not be retrieved. The second is the semantic gap between query words and post content. The same semantic can be expressed in multiple ways. When the query words and the post content do not use the same expression, the probability of retrieving the target post will be greatly reduced. In this example, anaconda can be expressed as anaconda and conda. Reduced disk usage can be expressed as clean up, free disk space, take too much space, etc. When users are not satisfied with the query results, they can only try to improve it by query formulation. However, it is difficult for developers to complete such a query formulation, especially for novices. In our study, we want to propose a query formulation model to learn the user's reformulation patterns, and when given the user's original query, the model can directly output the reformulated query that better helps the user to find satisfactory results compared with the original query. To investigate the feasibility of an automated query formulation model, we first conduct an empirical study based on Stack Overflow's activity log dataset. The dataset used in this work is the activity log of 9 million users on Stack Overflow from December 2017 to November 2018, provided by Stack Exchange Inc. The dataset contains 42 million activity logs from 16 million sessions. The graph on the right side shows the trend of number of activities, queries, and sessions per month in the year. Based on this dataset, we conduct an empirical study. First, we explore the user's query characteristics. The results show that software terms such as programming languages, data structures, and API names occupy the majority of the most frequently used query words. The average number of words in the query is 3.6, and the median is 3. 8.74% of the queries contain advanced search syntax, with tag filtering, user filtering, and special phrase declaration being the three most commonly used advanced search methods. Then, we explore the user's query formulation patterns. 8 patterns are recognized by manual classification, of which adding programming language or platform restrictions, spelling and syntax checking, and adding detailed requirement being the top 3 most commonly used patterns. Although only 8 patterns are shown here, the formulation strategy for each pattern vary across programming technologies. It is almost unrealistic to implement the query formulation through rule-based heuristics. Finally, we explore the scale of modification during query formulation. The results show that in about 60% of the query formulations, the similarity between the original query and the reformulated query is greater than 0.7, whose character level modifications is approximately equal to 1 query word. We believe that such query formulations that contain minor modifications will not lead to changes in query intent and can be implemented by query reformulation models. Based on the results of the empirical study, we believe that it is both necessary and feasible to propose an automated query formulation approach. We propose an approach named Secure that first extract query formulation threads and construct query formulation pairs based on heuristic patterns, and then train a transformer-based query formulation model with these pairs, which can directly output reformulated queries when given an original query. The model for encoding of the original query and decoding of the reformulated query is based on transformer. The original query is tokenized by a byte pair encoding algorithm, which can segment k-mole or snake case terms, misspelled terms, and terms with prefixes or suffixes. When generating the reformulated query, bin search is used to maximize the probability of the output sequence. To evaluate the performance of our approach, we state 4 state-of-the-art baselines: language tool, a grammar error correction tool; Google Prediction Service, a service to generate the predict query in Google Search drop-down box; sequence to sequence, the most popular model for machine translation; and herd QS, a hierarchical query prediction model. We evaluate the performance of secure and baselines from 2 aspects. The first is the difference between model output and manual formulation. The second is the retrieval performance of the reformulated queries. ExactMatch, GLEU, and M-square are used to evaluate the difference between the model output and the user's manual reformulation. The results show that Secure outperforms all state-of-the-art baselines by significant margins in terms of all metrics. Even compared with the best baseline approach, sequence-to-sequence with attention, Secure still achieves 5.6% and 4.75% improvement in terms of ExactMatch at 10 and GLEU. Further analysis of Secure's query reformulation results show that Secure can implement many query formulation patterns that cannot be achieved by the baselines. For example, correct misspelled terms bumpy to NumPy, which is a library for matrix operation in Python. Remove specific information in the query, for example, variable names, IP address, URLs, and file paths. Replace symbols with corresponding text, etc. A good query formulation model must not only output reformulated queries similar to manual reformulation, the queries must also be able to retrieve the desired post. We designed an evaluation experiment to compare the retrieval performance of different approaches. The original query and the query formulated with each approach are used to retrieve the desired post respectively. Then, the retrieval performance is evaluated. The experimental results show that Secure outperforms all the baselines in terms of mean reciprocal rank and achieves a 129.33% improvement compared to the original query. Finally, to facilitate the use of our approach, we implement a query formulation plugin for software-specific queries based on TemperMonkey. 10 candidate query formulation results can be generated for selection. You are welcome to scan the QR code to try out our plugin. At the end of my report, I would like to summarize the contributions of our work. First, based on large-scale activity log dataset provided by Stack Overflow, we distill unique insight into developers' query characteristics and query formulation patterns. Second, based on the results of the empirical study, we propose an end-to-end query formulation model. Third, by comparing with 5 state-of-the-art baselines from 2 aspects, we demonstrate the superiority of our approach. At last, we design a query formulation plugin to facilitate developers' use of our proposed query formulation model. Thank you for listening, and if you have any questions or suggestions, please don't hesitate to let me know.
And we are live. Welcome to the Q&A session The second paper of our session. My name is I'm from Eindhoven University of Technology in the Netherlands, and it's a great pleasure for me to announce that this paper has won the ACM SIGSOFT Distinguished Paper Award. I think it deserves a great round of applause. And we have two authors with us here, and Train Young. Happy to answer your question. And our first question is from Sridhar Chimalakonda, who is asking whether considering other comments and on the Stack Overflow post can be used to reformulate queries.
I will answer this question first, and from my opinion, that all the content, including questions and answers on Stack Overflow, is just in the software engineering field. So the comments and answers on Stack Overflow posts can be used to train word embedding, for example, and used in our query formulation model, since our query formulation model must need to first encode the input queries, that is the original query, and output the reformulated query. So we think this domain corpus can be used to enhance the understanding of the query for our query formulation model. Yeah. What about thinking, Chunyang?
Sridhar? Okay, sorry if I pronounced wrong. So that's a very good idea, actually. We also take that into consideration. But we don't. We got the data from Stack Overflow company, and so far we only have that query log data, and now we can now link the query log data given by Stack Overflow to the comments or answers in the Stack Overflow. That's why we don't use that, but it's a very good idea, and we may definitely maybe try it in our future work. Thanks a lot.
We have a couple of questions from Lin Yang. The first question is about the evaluation metrics in the GEC task. So why did you use those evaluation metrics instead of the metrics you have used in the NMT task? It's a rather technical question.
This is a really good question, and in our proposed method, the implementation of the query formulation is similar to machine translation. That is, the model takes the original query as input and output the formulated query. And it seems that the original query is translated into the reformulated query. But the task itself is more similar to the GEC task, which is called the grammatical error correction task. That is, some errors and unreasonable points in the original query are corrected to obtain the reformulated query. And if the evaluation matrix in the NMT task, such as blue chief, is used, the n-gram overlap between the original query and the reformulated query will be always be high. And even the query formulation model doesn't make any changes. That is, it directly copies the original query. The evaluation results will still be promising. However, if the evaluation matrix in the GC task is used, not only the n-gram overlap is considered, but also the modification during the query formulation are also considered. If you leave the original query unmodified, the result will be really bad. So we believe that evaluation matrix in the GC task can better evaluate the performance of the query formulation model. Yeah.
Thank you very much for your answer. And another question from Lin Yang is on determining the original query and the reformulated query.
Okay. Thank you for your question, and this is just the key point of this paper. And The identification of the original query and the reformulated query is achieved by using a heuristic pattern. The pattern corresponds to such a scenario that the user first executes multiple queries consecutively, and for example, query 1, query 2, and query 3, and during which the user doesn't click any query result, and after query 3, the user clicked a query result. We conjecture that the query 3, the last query, is a good query compared with query 1 and query 2. The user manually reformulates the query 1 and query 2 into the query 3 to obtain the reformulated query result. So we label the query 3 as the reformulated query and the query 1 and query 2 as the original query. In our implementation, we make it more greedier, which means that the post-visiting event is allowed in the pattern, but it must follow some restrictions, which makes the pattern more robust and improve the accuracy of predicting the original query and the reformulated query. And detailed information about the extraction of the query formulation thread can be found in our paper. Okay, that's my answer.
Great. Thank you very much, Kagabo. And I also see that a link to the GitHub. So if you are interested, you can just consult it. So we also have a question from Eleni Constantino. So Eleni wonders how your approach would be incorporated in the actual search workflow in Stack Overflow. So like user type, and then the recommender proposes a reformulation.
Yeah, that's a good question, and it can be seen from our paper that we implement a query formulation plugin, and we have pasted it on the GitHub site, so you can just click the link to see our plugin. When you are using Stack Overflow, for example, and you enable our plugin, when you are entering your query, and for example, you click a shortcut key, and the reformulated query will suggest in the drop-down box of the query box, so you can just click any of it that is the reformulated query that our model generated, and you can use that reformulated query to execute the query and get your query results.
Great. So I'm very excited about this part of your work, essentially, that it did not stay at the level of an experiment, but you actually made a plugin that people can use and benefit from your. So great job. So I was kind of wondering whether it would make sense to try to personalize a little bit, because the words we are choosing and the mistakes we are making might be reflective of our, for instance, first language. You know, for many developers, English is not their first language. So would it be a good idea?
Since when doing the paper, we have read the policy of Stack Overflow that Stack Overflow doesn't encourage the use of non-English words on their side. So when doing this work, we choose English as a primary language, and we does not consider other languages. So, and for other sites, and we can take this into account, and this will be our further work. Yeah.
No, but I mean, I didn't mean English words, but just the mistakes we are making in English.
Oh, mistakes. Do you mean the mistyped word?
Mistypes, wrong words.
Okay. Yeah, this is a really good question, and the mistyped word can be directly recognized by our confirmation model, and we have presented in the paper that many examples that the mistyped word can be directly fixed by our confirmation model, and when the model takes the mistyped word as the input, and the model will somehow recognize that this word is a mistype.